All right, I messed up in the last take on this, so I have some things written down already. This problem on the lottery is very similar to the birthday problem. You should review that. They're very similar. In this problem, we're asked first, what are the odds that you lose for the next 20 years playing every week? There are 1,040 weeks in 20 years. The odds that you lose on any given week is this messy looking fraction here. These are independent events. The odds that you win or lose next week are not affected by the odds that you won or lost this week. So the odds that you lose all 1,040 of those attempts would be the product of these events. This is just like the birthday problem, where we figured out the odds of all the no questions. The odds of somebody saying, no, that's not my birthday, are pretty certain. But if you raise this to a very big number, it becomes a very reasonable number. The lottery, the odds are a lot longer. So playing the game for 1,040 consecutive weeks, the odds are still 99.97 that you lose. So you're pretty certain to lose every week for 20 years. That does mean that your odds of winning at least once are 0.03%. It's 100% minus the odds of always losing. What about in a single week where 500,000 tickets are bought? Well, under some mild assumptions that the tickets are all different, which is probably not the case, assuming that these tickets are all different and that the odds of one winning or losing don't affect the other, then it would be like playing the lottery 500,000 times. So if we want to know the odds, what are the odds that there are no winning tickets this week? Well, it's the odds that one ticket loses times itself over and over and over again. So if I use my handy dandy calculating machine, let's see, 388. There we go. And I raise that to the 500,000 power. I get 89.5% roughly. So that's 89.4%. In the case where it's a million, which is what I asked the afternoon group, if it was a million, go up here and I can just change that to a 1, add a 0. That would be 80%. In either case, the idea of this is that these are the odds of every ticket losing. So losing. So the odds of at least one winning is 100% minus that. So it would be either 11% or 20%, depending if you were my 8 a.m. or 2 p.m. section. These are much better odds. This means, right, there's like a 1 out of 10 or a 1 out of 5 chance that somebody's going to win. Even though when they win, which is the follow-up question in this part, they feel these odds against them. The odds that Kevin Roberge plays the lottery and loses is this. It's almost certain. The odds that Kevin Roberge plays the lottery, the odds that Kevin Roberge wins the lottery and wins is slim. It's this. The odds that somebody wins when lots of tickets are sold is pretty good. And again, the more tickets that are sold, the more likely you are to have a winner. So it's not a surprise when somebody wins the lottery. It's a surprise when you win the lottery. And that's really the nature of struggling with these coincidences.